Hello guys and very warm welcome to in this our YouTube channel, and in our today's lecture we are going to learn the same topic, that is modern periodic table, the next part of this chapter. Now students, we are in the topic of modern periodic table. In our last lecture we have seen some different blocks of the periodic table and their trends. In continuation with that previous knowledge, students, in our today's lecture we are going to learn the different parts of this periodic table and how to write the electronic configuration in the given periodic table. So let us start with different blocks. Students, you are already familiar with these four blocks. In this previous lecture, previous slide, we have already shown with different colors. Look at this: S block, P block, F block and D block. And the assigned group you have mentioned here, S block is of group 1A to 2A. We are calling it as a representative elements. And if you look at the group 3A to 8A, they are called as a P block elements. They are called as a also representative elements. And students, the next part of the periodic table is nothing but the D block. Group 1B to 8B are called as transition metals. And the last part of this periodic table is F block. They are called as the inner transition elements. Now students, the very important points to be considered while determining the electronic configuration, or you can say the position of elements in the periodic table. Here are the some important points that we have to take into account. The number of electrons in the outermost energy level or the valence electrons resembles to the group number. So this is a very familiar point. If we go through the periodic table, you will notice here the number of electrons in the outermost energy level or the valence electrons, we are calling it as a, which represents to the group number. Means if we consider the potassium which is present in group 1, in its valence shell there are number of electrons are 1 because it comes under the group 1. And like that of, if we consider the magnesium, it comes under the group 2nd. In its valence shell there are 2 electrons are present. So this is the, what I can say, which resembles to the group number. And the second thing is that the highest main energy level occupied by the electrons of the atom corresponds to the period where the element is located in the periodic table. Means the highest main energy level occupied by the electrons which corresponds to the period. For example, if we consider the magnesium, or you can also take the simplest example, carbon, which corresponds to the period where the element is located in the periodic table, means it represents the period number. Configuration of valence electrons of representative elements. S and P sublevels, or you can say the subshells. N represents the number of highest main energy level, and N is the, we are also called as a, N is same as the period number in the periodic table. Students, if we go through different families, or we can say group, we have assigned a group number to each family, and the general valence electronic configuration at the same time we have mentioned in front of them. Now look at here, the first A has the general electronic configuration is ns1, and second A is ns2. Means if an element comes under the second group, in its outermost or valence electronic configuration will show like this. means if it comes under the second period it will be 2s2. If it comes under the first, you will get here 1s1. Like that, the general valence electronic configuration for different groups have shown here in this table. Now if we took an example of magnesium which belongs to group 2a period 3, so you will notice here atomic number of this magnesium is 12. So if you look at here the electronic configuration, you will get here 1s2, 2s2, 2p6 and 3s2. Students, this should be very important point that you can understand with this example. It falls under the third period and second group. So the numbers which are shown 3s2, what they represents, 3 indicates it comes from the period 3 and second group. That earlier in our previous slide we have mentioned their illustration. And like that, if we take the different examples also, arsenic which belongs to group 5th and period 4, and the atomic number of this element is 33. So in that case you will get the electronic configuration like this. Its valence electronic configuration, if we consider here, it represents it comes from the period 4 and group 5a. Means if we consider here the 4, it falls under the period 4 and group 5a. Chlorine belongs to group 7th A period 3, which is having atomic number 17. If you look at here the electronic configuration of chlorine, you will get here 3s2. 3 indicates it comes from the period 3 and which belongs to group 7a. So this is the representation of the elements, and if we add their powers 2 plus 5, you will get the 7, means chlorine belongs to group 7a. Previous one also you can apply the same things to the above example, that is arsenic. In this case also the group 5a you will get with the addition of electrons in the valence shells, that is 2 plus 3, you will get 5, that is it comes from the group 5a. Now students, let's try these examples also, and you can also mention their answers in the comment box. You can also try with these some examples: sodium, calcium, oxygen, and all these electronic configuration you are already familiar with it. So you just go on solving these examples and show them in comment box whether they comes from which group and which period. Now moving to the next slide, configuration of valence electrons of transition elements. S and D sublevels, that is we are calling it as a transition elements. S and F sublevels, we are calling it as a inner transition elements. N represents the number of highest main energy level, and N is same as the period number in the periodic table. Now here are some examples. We will go in detail about these examples. Students, first of all we will consider with iron, which is having atomic number 26 and which belongs to the group 8b and having period 4. So let us go in detail about the electronic configuration of iron. You will get here the valence electronic configuration is 4s2 3d6. This is the d6 case, and if you look at the period 4, when it belongs to the period 4, its electronic configuration, valence electronic configuration will show 4s2, and the general electronic configuration of d elements is n minus 1, so you will get here 3d, and at the same time their powers, that is number of electrons in the valence shell, they indicates 2 plus 6 means you will get the answer 8, so it belongs to the 8b group. Now students, let us go with the next, that is another example of technetium which belongs to group 7b period 5, and at the same time which is having the atomic number 43. So if we illustrate here its electronic configuration, it comes from the period 5 and having group 7b. So you will notice here its outermost electronic configuration, that is valence electronic configuration, if you add their powers you will get the again the same things. Berkelium, which is having atomic number 97, comes from group 1b period 7, their electronic configuration is also we have mentioned here. So you can also just try by taking these examples too, that is manganese, zirconium and gold. Students, for your practice you just try with these examples and mention in comment whether they comes from which period and which group, and show the electronic configuration of the elements in detail, whether they get matches with period number and the group or the family, just mention in the comment. Now let us go to the next point, that is the reactivity of elements. Students, you are already familiar with octet rule. On the basis, in understanding the properties of the elements, states that atoms or ions often react to obtain exactly 8 electrons in their valence shell, that we already learned. Alkali metals, group 1a of the periodic table, all are very reactive in their elemental form. They are very soft, lustrous metals. They form compounds with the halogens. For example, if we take example of sodium, it will form compound with chlorine, that is NaCl. Similar to table salt, a compound formed by sodium and chlorine, just only we have mentioned. Halogens, they comes from the group 7a. They are very reactive. They form compounds with alkali metals, as earlier we have seen with example. Sodium chloride is a very stable compound because both the sodium ion and chlorine ion has 8 valence electrons or a complete octet. Next category, that is noble gases, group 8a, have complete octet, very stable, unreactive gases. Physical and chemical properties can be predicted from their position in the periodic table. Now students, this is the classification of elements. If you look at this chart, you can also take the screenshot, and you will find here different uses, means in our day-to-day life where we are using these elements or where we can find these elements and their applications. So all these elements are very important, they are the part of our life. You will classify or you can study in detail about these elements. So this is all about in our today's lecture. Thank you very much.